Hey guys, I'm gonna try this again. This time, hopefully, the audio works. I'm not sure what the issue was last time, but we'll go through this lecture one more time. So today we're doing vectors in a plane. So let's start off with the definition of a vector. Okay, a vector is an object that can be characterized by its direction and magnitude. Okay, we use V and W with those arrows above it to show to represent vectors. Okay. So sometimes I'll also do like these little half arrows like that. So you might see me write something like that sometimes. Same thing, just talking about vectors. Okay. The primary application of vectors is to represent physical forces. Okay, so we're talking about speed and velocity. So speed is the magnitude of velocity. We got to remember velocity has a direction and a magnitude. Okay, so like velocity, vectors have a direction and a magnitude. Okay, so let's identify the difference between some of these things, so it'll help us when we're doing these word problem examples. So you're traveling 50 miles per hour. This is an example of speed. Okay, right? Just a magnitude, no direction. Okay, next one, you're traveling north at 50 miles an hour. Okay, this one, it's got a direction, it's got a magnitude. We're talking velocity. Okay, we're talking velocity. Next one, the winds are from the southwest at 15 miles an hour. Okay, this is also velocity. We got a direction, we got a magnitude. Okay, think about it. It's going, and here's another thing. Think about this. Which way is the wind actually going? It's going that way. It's going to the northeast. Okay, right? It said it's coming from the southwest, so make sure you guys understand that when you're doing some of these story problems. Okay, so a vector with a given length and direction can be located anywhere in the plane and still be considered the same vector. Okay, the vector starting position or initial point does not matter. Okay, a vector that is located with its initial point at the origin, okay, that starting dot is at the origin, is said to be in standard position. Okay, so all they're saying is that dot is right there at the origin and the arrow's coming out from there. Okay, that's when it's at standard position. Okay, that's its initial point. So for like the winds are coming from the southwest, right? We have a magnitude of 15. Our initial point's at 0 and it's going to the northeast. Okay, so let's keep moving on down. We're going to practice graphing some of these points in polar form. So I'm going to give you a couple points. Start with point A. We'll say 135 degrees. Okay. We'll do B will be 530 degrees. And C will be 270 degrees. Okay, we're graphing these polar points. So, start with A. We got a magnitude of 4, right? This is our R. Let's not forget our R and our theta. So we got a magnitude of 4 and we're going 135 degrees, okay? Start at your polar axis, head that direction. We're going to come to a point that's a little bit out. It's about right there. Okay, right, we're drawing it out. Hopefully you draw a better line than me, but draw it out from the origin. Okay, that's your point A, or your vector A, excuse me, these are vectors. Okay, for B, we got a magnitude of 5 and we're going 30 degrees. It's going to be about like this. Right out there. Okay, and C, this one's pretty easy, right? We got 3 and we got 270. Okay, so we know 270 is just going straight down that negative y-axis. Head down 3, and you got your point C. okay? Right? If we were talking about a direction, we could say this is 3 miles per hour headed south, right? Okay, you could say B is like 5 miles an hour headed 30 degrees north of east. Okay, what they're saying is this is east, this is north, we got west, we got south. So B would be 30 degrees north of east. Okay, the only time we're going to use northeast, northwest, southwest, things like that is when we're talking about exactly in between those 90 degrees. So northeast, whenever you hear northeast, it's always 45 degrees. Okay. North of east, though, is talking about how many degrees you are going north of the positive x-axis, the east axis. Okay? So, moving on, a couple more definitions. Okay, we're going to talk about polar representations of vectors. If all vectors under consideration lie in a single plane, then the vectors are plane vectors. Okay? Or they're two-dimensional vectors. That just means that they only deal with two components, like they only deal with x and y. Okay? The definition, or in this case, it's not x and y, it's the polar definition, so we're dealing with r and theta. Okay, so the polar representation of two-dimensional vectors v with non-negative magnitude r and directional theta, okay, and we're measuring clockwise. Okay, so it's represented the same way we write polar form points. Okay, that's the way you represent a vector in polar form. Okay, it's talking about, you always start from the polar axis, right? If we got a positive theta or negative theta, tells you which direction you can go around. Okay? Remember, we can also talk about it from each axis. If we say north of east, we're going from that positive x-axis. If we're saying north of west, we're going north or up from the x-axis, okay? Think about those different ways to represent on the graph. Okay, component representation. Component, that's just the same thing as writing rectangular, okay? It's just rectangular. Okay, same thing. That's what they're saying component is. Okay, the component representation of a plane vector V is the ordered pair V1, V2. Okay, instead of writing X and Y, you're writing V1, V2. Okay, the rectangular coordinates of the point at the tip of the standard position arrow for V. Okay, so that point, or that the way they represent those two components, that's the tip of the vector when it's coming out of the origin. Okay, the numbers V and V2 are the X component, so are the X component and the Y component. Yeah, so that's like what I was saying. V1 is your X component, V2 is your Y component. Okay, so now some examples, finally the good stuff. Okay, a storm is traveling at 30 miles per hour in a direction of 15 degrees north of east. Okay, so think about this. They're talking about 30 miles an hour north of east, 15 degrees. I'm going to guess that's about 15. Okay, remember we got our north, our east, our south, our west. This is about, we're going to say 15 degrees, and we got a magnitude of 30 miles per hour. Okay? That's degrees. 15 degrees. 15 degrees, 30 miles an hour, and it's going north of east, right? North of east. Okay? The second one says write the polar representation. Okay? We're just going to take our components are in our polar form, and we're going to write it. Our R is 30, right? Our magnitude, and our direction is 15 degrees. It's as easy as that. For the next part, it's asking us to write the component representation now. So we need to write it in terms of our X and Y. That sounds like we're going to need to do a little converting, okay? So we take our R times, remember, the conversion is R times cosine theta, sine theta, which is 15. Okay, that got me something like 30 0.97, right? This is calculator. This whole chapter is pretty much calculator. Okay, and that's going to get us 29.1, 7.8. Right? Just did our conversion. Stuff we just got tested over last chapter, or almost got tested over. So describe the storm's movement each hour in terms of the number of miles east and west, and the number of miles north and south. So they just want us to take our components, okay, what we just did right here, and turn it into something that answers the question, okay? Like we got to use some words, okay? We got to use our units. So all they're saying is we're going positively 29.1. So we're going to go down the x-axis 29.1. In this case, the x-axis, right, is east. Okay, so we're going to say, hey, we're going 29.1 miles east. Okay, and the next part we want to determine in terms of north and south. We're going to say, hey, I'm going 7.8 miles north, right? Because that's a positive y value, positive v2 value, so we're going up or north 7.8. Okay? A lot of these problems are just thinking problems, okay? Think about the question, understand what it means. Okay? A lot of good problem solving skills to get out. Okay, let's jump to number 2. It's asking us to consider the vector that's from 2 points. Okay, so remember, what we can do, I'm going to give you guys a little formula, and I mean, this is really just finding the distance between 2 points, but it's how you find the vector from standard position. Okay, so when you get 2 points and they say there's a vector between these 2 points, if you want to turn it into a standard position, what you're going to do, okay, you're going to take your A, B, let's say, to C, D, right? We're going from that point to that point. Your new x value is going to equal C minus A, okay, right? Our x2 value minus our x1 value. And then we're going to have our, y is going to equal our D minus B. Okay, all we're doing is doing end minus beginning. Okay, do your end minus beginning, and it's going to give you your standard position. Okay, so for A, it's saying draw the standard position of this vector. So when we do that little equation we just talked about, we got 1 minus negative 3, right, for our x values, and we got 5 minus 2. Okay, that should give us 4, 3. Okay, so if we graph those first points, we got negative 3 up 2, and we got 1, 5. Okay, so that's your original, oh boy. That's your original point. And then now we got, from the origin, right, we found the standard position. We got 4, 3. Okay, see how just doing that shifts it to standard position. Okay, another thing you can think about is if you want to look at your original vector that we have here in purple, okay, you look at that and you say, okay, I know I got to get my starting position to 0, 0, so you can count to 0, 0. Okay, and what I mean by that is you count down. You go 1, 2, down, and then you go 1, 2, 3, over. You can say that's how I got my bottom point to 0, 0. So you can go up to your tip top point and go 1, 2, 1, 2, 3. Okay, and see how that got you that 4, 3? That's all we're doing. We're shifting our vector to standard position. So if you ever forget that little, C minus A, D minus B thing, you can always do it graphically by shifting it. Okay, so find the length and direction of the vector. Okay, so now they want to find the length and direction. That means we need to convert it to polar form, right? That gives us a magnitude, it gives us a direction. So our R equals the square root of our x squared plus our y squared. Okay, which equals square root of 25, which equals 5. All right, our theta is going to equal inverse tan of 3/4. Okay, and what do you know? Calculator problem, 36.9 degrees. Okay, and that's all they're looking for. We got our magnitude. Like that. Boom, magnitude and direction. Okay, moving down to number 3. Okay, a person is exerting a force of 80 pounds in a direction of 22 degrees east of north. Okay, east of north. Pay attention to that. Okay, what are the x and y components of the vector? So they want our final answer to be in rectangular form. So first, let's look at what this is saying, okay? They gave us a magnitude, they gave us a direction, but let's pay attention to the direction. Okay, they said east of north. Okay, if this is our north and this is our east, they're saying 22 degrees that way. Okay, so that's where our vector is. That's our 22 degrees. But we want it in terms of our polar form, which is always coming out of our polar axis. So what we got to do is, we know we have 80. Okay, and we got to do 90 degrees minus 22 degrees. Okay, that's going to get us 68 degrees. Okay. All right. I just did a little difference thing right there. Okay. So that's what I'm talking about. You got to pay attention to how things are worded. 22 east of north. We're going east from the north axis. Go east 22 degrees from the north axis. It's the same thing as going 68 degrees from our polar axis, which is the east. Okay? So now we got to convert it to rectangular form. Okay? That's going to be our r, our 80, multiplied by our cosine of 68, sine of 68. Okay? Calculator problem. Gonna get 30 and 74.2 as your points. Okay? Now, moving on down to what a norm vector is. Okay, the norm of a vector. It's going to look like something that's absolute values. Okay, so it's just our vector u, and it has absolute value type bars around it. Okay, it denotes the length or the norm or the magnitude. Okay, right? The magnitude of u. So remember, in polar form, the magnitude of u is our r, right? Right here. It's our r. So all they're asking for is when they say the norm of a vector, they're asking for the r in our polar form of the vector. Right? Polar form of a vector is just r and theta, so they just want the r. Okay, u is the whole vector, the vector as a whole. R is the norm. Okay? So going down to the norm of a vector theorem. Norm of a vector theorem. They're just saying that if u is a vector with components u1 and u2, then the norm of the vector is just our formula for r, right? It's our u1 squared plus our u2 squared. Okay? Those in parentheses. Right? That just equals our r. They're showing you how they both equal r. There's different ways to show it. Okay? We're just showing a lot of symbols and a lot of ways to show the same thing. Okay? Equivalent polar and component forms theorem. Okay? For all plane vectors u. All right, when you have the norm vector, right, this is just our polar form. That's the same thing as r theta. They wrote it in just a different way. It still equals our or our u norm cosine theta sine theta. Okay, it's just still our same formula. Okay, we just did the exact same thing as r cosine theta, r sine theta, right? That's the same thing. gives us our x, our y. Okay, that's all we're doing. We're showing how all this is interconnected. Okay, and the last thing for today, the point 0, 0, okay, in rectangular, it corresponds to the 0 vector, right? This is the symbol for the 0 vector. That just means it's a point, right? It is just a point because it has no direction. It's sitting at the origin. It has length 0 and it can go in any direction. Okay, the other thing, vectors 0, 1, and 1, 0 are just unit vectors. Okay, they're 1 unit vectors in the positive directions on the positive y and the positive x. They're called unit vectors. They just have length 1, and usually you're going to see the I and the j. Okay, so all that really is there is, you know, when you're looking at work or if you ever look up different problems online, that's what they're referencing. Okay, have a good one, guys.